Hey there, finance friends. I wanted to make a quick recording to just give us a little bit of extra practice around time value of money and around how to use the calculator. So, as you know, we'll start up just a little quick thing here. We have this idea. Let me actually change this. We have this idea of the time value of money, which we can call TVM. And the big thing about this is ultimately we're looking at money moving across time. So we know that we can move from the present value to the future, to the future value in a process called compounding. We also know that we can move the other way. We can actually have a future value and pull that back to the present. At the end of the day, whenever we're doing solutions with time value of money, and it's a really critical skill to have, we're looking at moving money from the present to the future or from the future back. The amount that we move is either going to be a lump sum or possibly, so it's either going to be a lump sum or possibly, if it's an annuity, a payment. Lump sum, one time thing that you're putting in and it grows, or a one time amount that you want and you're saving toward it. Annuity is a series of payments. But don't be too tripped out by it. Whether it's lump sum or payment, we're either going from present to future or from future back. The other variables that we're talking about are N, which is the number of periods, and I, which is the interest rate. So anytime we're either going from present to future or we're pulling from future back to present, we're looking at the speed of money, which is measured as the interest rate, and we're looking at how many periods that money's traveling, which is our N. Every financial calculator problem is going to have 5 potential variables. 4 of them you'll either be given or you'll kind of suss out and figure out. The other one is the one that's missing. And that's the one that you're going to use on your calculator. Our 5 variables, again, present value, future value, N, I, and PMT. I'm going to share, hopefully it goes through. I'm going to share with you guys a financial calculator page. This is the one that we use in class. And let me make sure that this went in. Okay, looks like we have it now. What we see here is a financial calculator page. You notice that up here, we have the 5 variables. 4 of them are in blue, one's in gray. So we're going to click the variable that we're trying to find. It's like a scavenger hunt. I give you 4 variables, you got to find the missing one. So it's like a scavenger hunt. So let's say that we want to find the future value. You click FV for future value. FV goes gray, and the other 4 variables, PMT, interest, N, and present value, they go blue, and they also have corresponding things here so that we can enter values in. And then we just calculate and we're done. So that's the first thing to bear in mind. Let me get out of here. Actually, I think I can do it up here. Let me go back to my screen. Or, I'm sorry, go back to my notepad, I believe. And here we go. Yep, I think we're there. Okay. We're here. We're going to have these 5 variables. We're just going to find the one that's missing. We're going to enter data in and pull it out. Calculate it, and we're good. The other thing that could be a little confusing is the sign, positive or negative. Don't be tripped out by it. Simply put, anytime you're contributing the money, that includes putting it into an account. Anytime the money is leaving you, that's going to be a negative. The money leaves you. You're sending it out. And anytime the money is coming in or it's going to be received, it's positive. That's all you got to do. So that's the basics. What I've done is you have a homework assignment for this time value lecture, and there's like 20 questions on it. But to help you out, I've decided to do a little tutorial with you. These questions on this tutorial are very similar to the homework questions. So if you go through this and get your practice, then you can apply the knowledge from this to your homework. So let's try to jump through these things really quick and see if we can suss them out. We're starting off with future value questions. Then we're going to go to some present value, and then we'll get some extensions and maybe even some applications. Yeah, applications to saving and investing, and then some applications to borrowing and debt. And I think we even got a big one for retirement planning. Okay, so go through this. You don't have to watch the whole thing. If you need, you can just fast forward. If you have problems with the homework, fast forward in this video to the area where you get the solution. Okay, so let's just do some samples. You put $2,000 in the bank today. How much will you have in 6 years if you earn 7% per year? So we know that we're given the present value. You're putting 2,000 into the bank today. So that's going to be negative 2,000. Negative because the money's going out. And it's going to be 6 years. You're earning 7%. And because this is a lump sum, the PMT is going to be 0. So we're solving for the future value. That's what we're solving for. And just really quick, let's just try this. Let's see if I can make this clean. Hopefully it's not too clunky. And I think I have to stop my sharing here. Yeah, we go here. We have a financial calculator. Let's clear this. We're solving for the future value. So we've clicked it and it's in gray. And we know that our present value is negative 2,000 because we're sending that money out. Even though we're putting it into our own account, it's leaving us and going into the account. We know we're going to grow this money for 6 periods. The interest rate was 7%. And because it's a lump sum, it's going to be a 0. We've got our 4 variables in. Now it's time for the scavenger hunt. Hit calculate, and you have the answer, 3,146. Okay, let's go back to our handout. And let's get that up. And I'm sorry this takes so long. And there we go. 3,001.46. What does this mean? Well, money's traveling through time. If you put $2,000 out today, if you put $2,000 out today, and that money grows at 7% for 6 years, that will eventually grow to $3,001.46. So that's how we're going to work these things. For the rest of the problems, I'm just going to work out with you the variables for the scavenger hunt, and you can go in and plug them into the calculator on your own. If you have any questions, shoot me an email or bring it to class and we'll get you sorted out. Okay? So look at number 2. Now we're saving $2,000, but it's per year. So now if it's every year, we're out of lump sum and we're into an annuity. We're into an annuity because we're making an equal series of payments over time. So in this case, present value, 0. We didn't put anything in as a lump. And it's still going to grow, this time for 10 years. It's going to grow at 6%. And critically, the payment is $2,000. That's going to be going out. That's a PMT. Probably the best way, pause this now, plug those into the calculator, and then once you get the answer, come back and let's see if we got the right solution. And I got, when I put this in, so again, we're solving for future value, I pulled down the value of 361.59. Number three, you save 1,000 per month at an annual interest rate of 18%. How much will you have in 20 years? Now, straightforward question, but there's one little complication. We have to keep our terms, our terms in terms of the month or year or week, keep our terms constant. And if you notice, an annual interest rate, that's annual. 20 years, that's an annual measurement, but we're putting in 1,000 per month. So we've got to find some way to get month and year on the same thing. We're going to make this by month. So we're going to put $1,000 a month in. That's easy. And because it's an annuity and not a lump, we know that PV is going to be 0. So we're going to say if we put 1,000 in a month, how will it grow? And we know that money grows in relation to N and I. But the problem here is N and I are annualized. So we make a couple of adjustments. For I, we divide 18% annual divided by 12, and we get 1.5%. This 1.5% is the monthly interest rate. If the annual was 18, you divide 18 by 12 months, you get a monthly rate of 1.5%. And equally, since it's 20 years, but we're talking about months, and there's 12 months per year, this is going to go to 240. Notice as you get practice and a bit more fluent and build some intuition with this, you'll notice that you always, in these kinds of problems, you're going to increase N and decrease I, and it's going to be by the same factor. So if you go from annual to monthly, increase N by multiplying by 12, decrease I by dividing by 12. If we were going quarterly, there's 4 quarters per year, you increase N by multiplying by 4, you decrease I by dividing by 4. So keep that little inverse connection right. Focus as you're getting fluent with this concept and keeping your time periods constant, and you'll be okay. Plug this in to solve for FV, and I got $2,308,854.37. And that's not a bad chunk of change. And that shows you the power of time, and it shows you the power of increasing your compounding windows. Okay? So that's some future value questions. Now, let's turn it around. Let's solve for present value. The present value questions are actually a lot more interesting in finance because a lot of your financial journey is going to be you have a goal. It's out there somewhere in the future. And you know what you need. You know how much money that goal is going to cost you. You know how much you're going to need to send a kid to college or how much you want in your retirement nest egg. So then you pull that back and ask, what do I have to start doing now? So I love these present value questions. To me, they're more valuable than future value questions because these are really tied to action. What do I do right now? How do I start? What launches me? Okay, let's jump into it. So number 4, what's the present value of $30,000 paid 7 years from now at 9%? In other words, I promise to give you $30,000 in 7 years. Or in 7 years, you're going to need $30,000 for some goal or project. If money grows at 9% per year, how much money do you have to put aside today to get that 30 in the future? Or seen a different way, if I say to you, hey, I'll pay you $30,000 in 7 years, what would I have to pay you today to make it equal? Okay, so we're adjusting over time and interest. So back to the scavenger hunt. We know the future value is 30. We know it's 7 years from now. The interest rate is 9%. This is a lump, not a PMT. So that's going to be 0. So we're solving for present value. And if you plug your numbers in, you'll get $16,411.03. What does that mean? Well, it could mean that if you put $16,411 away today and that money travels through time at 9% for 7 years, it'll grow up to be $30,000. Or if you're entitled to $30,000 from me, I say, hey, I'll give you $30,000 in 7 years. And you say, hey, Eric, listen, I kind of need the money now. Give me the 30 grand now. I say, hey, slow down. I'm not going to give you 30 grand now because a dollar today is worth more than a dollar in the future. So if you need 30,000 in 7 years, I'll give you less than that now. How much less, you ask? Well, I'll give you $16,411 because 16,411 today is exactly the same as 30,000 in 7 years if it's growing at 9%. Okay. Number five, you want to have $18,000 6 years from now. So we know that we want 18,000 to be coming in. We know we want it in 6 years. How much must you save each year if the interest rate is 4? Interesting. Interest rate is 4%. But this question is, how much must you save each year? So we know that we're talking about a PMT. Since it's a series year by year by year, there's no lump sum, so PV is 0. But that's okay. Pause this now on the calculator, click PMT, enter your other 4 variables, get the scavenger hunt going. And you would get negative 271371. What does this mean? Well, it means that if you were to put $2,713.71 into an account every year for the next 6 years, and that account grew at 4%, that would generate 18,000 in that time. Okay. Also notice that it's a negative sign. This is because you have to put the money out to get the 18 grand in later. Okay. Let's do some extension questions. Suppose that you can save $6,000 each year. In 12 years, you want 80,000. What interest rate would you need to earn to get that? So in this one, we've still got our 4 and we're solving for our 1, but now we're solving for I. These are kind of important questions. If you say, hey, listen, I have money now, I need it to grow to a certain thing in the future, and here's how long, then you're factoring in the interest rate. So in this one, we know you can save $6,000 per year. Per year makes it a PMT. So we're going to put negative 6,000 because the money's going out. You know that you're going to want 80,000 in the future, specifically 12 years in the future. And because it's a PMT, it's an annuity and not a lump, we're going to put PV of 0. We solve for I. Before you learned the calculator, this would be a paralyzing question. But now you just changed the scavenger hunt. You've still got your 4, you plug them in, you solve for I, and you'll get 1.895%. And now you have a tool that will help you to figure out where you have to invest to get the required rate to reach goals. Okay? Number 7, you can save $6,000 each year. You want to have $60,000 in the future, and you can earn 14%. Now we're asking, how long will it take you? In the problem above, in number 6, we knew you had 12 years. You had to figure out the rate. Now you're told, okay, you can put aside $6,000 a year. You can grow it at 14%. That's healthy. It's still an annuity, so the PMT is 6,000 and PV will be 0 because it's not a lump sum. And in the future, you want 60,000 coming in. Well, now we're asking, how long will it take you? Remember, money flows through time, and getting from here to there can be achieved in a lot of different combinations of N and I. If you're given one, maybe N or maybe I, you can solve the other. So in this case, we would say, all right, if I put $6,000 a year, every year at 14%, how long will it take me to get to $60,000? Scavenger hunt. Plug them in, and you will get 6.682 years. So that would be, just over 6.5 years. And now you have another tool and you have a toolkit in front of you to solve not just simple problems of how much do I put to get that money in the future, but you can calculate for time and for the required interest rate to make these financial goals become realities. And that's the big thing with this stuff. As long as you can build a goal and put a price tag on it, time value of money allows you to translate abstract goals into concrete solvable challenges. And that's power. Okay. Number 8, let's move on. Another extension. You can earn 12% per year. It's going to compound quarterly. So that means that we're compounding 4 times a year. And you want 50,000 in 9 years. How much must you save per month? And right away you say, Eric, this is a toughie because first of all, we're solving for PMT. We know that, how much you're saving per month. But we're talking here saving per month, but our interest rate is annual and our time period is annual. So we've got some adjustments to make. Let's start with what we know. We know that we want $50,000 in the future. We know we're saving per month, so that's that's a PMT, not a lump sum, so we can put 0 here. Now, what's our N? Well, we have 9 years, but we're compounding 4 times a year, so our N is 9 times 4. There's actually 36 periods. I know it's 9 years, but if we're compounding quarterly, that's 4 periods per year. By 9 years, 36 is our periods. And I is going to be our 12%, which was annual, divided by 4, or 3% periodically. So this means that we're going to have 36 periods of 3% interest per, because we adjusted, and we're finally asking, how much do we have to save per month to make this dream happen? This is a tougher one because you got to do some adjustments, but once the adjustments are done, scavenger hunt. Plug them in, solve for PMT, and you'll get negative 790.19. What does this mean? Well, this means that if you set aside $790.19 a month into an account paying you 12% interest that compounds quarterly, in 9 years, it will grow to $50,000. So that's the basics. What are some applications? If you understand time value of money, you can map out and solve almost every problem in personal finance. And you have the power to really think deeply about planning. Oh, I can do this. I've got the toolkit. Let's do some applications. Let's start with savings and investing. So let's say that you deposit $6,000 annually into your Roth IRA. You expect to earn 8% average return. You want to retire in 45 years. When you're old and gray and angry, how much money will you have to ease your conscience and your soul in your account? What will, in other words, $6,000 put in an account every year? What will that grow to given 45 years and 8%? Well, easy. We know that we're putting $6,000 in every year. Since it's a PMT and not a lump, PV is going to be 0. We know we're going to grow it for 45 years at an annual rate of 8%. You've got your 4, get your scavenger hunt, and you will get 2,319,033.70. Okay? Again, experiment with plugging these numbers. Pause the video, go to the calculator, plug them in. If you have any problems or if your solutions aren't mine, come and talk to me or send me an email and we'll get you sorted out. I might have made a mistake or you may have a little tiny glitch in your calculator skills, but we can get it solved really easy for you, okay? Number 10, You plan to put 750 into your 401k every month. You can earn 8% annually. How much will you have in 30 years? Well, we've got to do an adjustment. So we know we're putting 750 in. If we're doing it every month, then our factor here is going to be by 12. So 30 years times 12 months per year is going to be 360. And 8% annual interest divided by 12 is going to be 0.67% monthly interest. And now we've equated our terms. PV is 0 because it's an annuity, not a lump. We're going to solve for future value. And in 30 years, you'd have a pretty healthy account with $1,126,888.12. Not too shabby. But now let's say you had started 10 years early. Suppose you let time be your ally and you started 10 years early. Let's see what would happen there. Well, we're still going to have 750 going out. We're still going to earn 0.67 per month, but now our months go to 480 because now we're talking 40 years. So we're adding an extra 10 years. In other words, we're saying, what if you let time be your ally and you started early? PV is still going to be 0. And look at this. $2,648,760.84. People who don't understand finance, they can't imagine. They say, you're getting more than double the money. You're getting more than double the money, but you didn't leave your money in for double the time. How is that possible? And that's that magic of exponential growth and compound interest. By starting early, those first 10 years had even more time to grow. Okay, so that's a lesson for you. Besides knowing the calculator, start early. Control what you can control. It's going to be real hard for us to control the interest rates that we earn. It's just going to be hard. But we can control when we start, so we can control N. And we can control how much we save, so we can sort of control PMT. And those two variables, you'll be okay. Okay? So there's savings and investing. Now, here's the problem. This stuff up here, numbers 9 and 10, looks beautiful when it's your money that you're saving, but the same forces that work against you, that work for you when it's your money, they work against you when it's not your money. So let's see how time value applies to borrowing and debt. Suppose you buy your first house, you get a 30-year mortgage at an APR of 4.5%. You take out a mortgage of $400,000. What's your monthly payment going to be? So this is a good kind of question. First of all, we're solving for PMT. We want to see, given these loan parameters, what's the PMT going to be? Now, it sounds like it's hard, but just remember, whenever you have a loan and you're going to pay it off, the future value is going to be 0. So we're taking out $400,000 of mortgage. That money's coming into us because we're borrowing it. So it's going to be positive. And eventually, we're going to pay it off. So anytime you have a payment like this to calculate, don't panic. Just know that whenever you're paying off a debt, you're going from a balance that you have to a 0 balance. You're just killing off the debt. We call that amortization. Okay? We had to do an adjustment. It's a 30-year loan, but we're making monthly payments, so that's going to be 360. And the APR is 4.5%, but the A stands for annual, so we have to divide that by 12, and that'll give us a monthly interest rate of 0.375%. Put those numbers in, solve for PMT, 202674. That's how much you have to spend. I shouldn't say spend. That's what your payment's going to be every month. Another way to look at it, it's a negative sign, so you're sending the money out. If you send out $2,026.74, you will pay off a $400,000 mortgage at a 4.5% rate in 30 years. Now, that's not good. That's a lot of interest you're going to pay. So, what if you say, Eric, is there a way that I can maybe pay off my mortgage quicker? Well, with time value tools, you sure can. Let's see number 12. In the problem above, now let's say that instead of making the established payment, you increase your payment by $200. So now instead of paying 2026, now you pay 222674. You're still taking out a $400,000 loan. You're still going to pay it off, so we're going to pay that thing off. Now, oh, the interest rate is still going to be 4.5% divided by 12, so it's still going to be this. So look what we're doing now. We're solving for n, and we're saying, hey, look, I'm not going to pay the original amount of 2026. I'm going to pay more with this extra payment. If you have the discipline to make an extra payment, we can calculate a new n, a new amount of time. Scavenger hunt. Plug the numbers in, and n is going to be 299.153. That's months. Divide that by 12, and we're talking just about 25 years. And look at that. An extra couple hundred a month to your payment, you're going to knock 5 years off of that mortgage. Think about the opportunity cost. If you pay that mortgage off 5 years early, think about all the other things that you can do with that money that was going out to the bank. You've recaptured that. You capture that wedge, and now you can make that money work for you. So that's how we think about things in finance. Number 13, you get a 30-year mortgage at 5%. Now look, you don't know how much the house costs, but you know that you can safely afford a payment of $3,300 per month. Now we can use our time value skills to calculate the max that you can safely borrow. You see, when you buy a house, a lot of mortgage brokers, they want you to take out the biggest mortgage you can take out because they make money as a percentage of that, right? So their incentive is to get you to take out a huge loan, buy a huge house. But if you buy too much house and you starve your cash flow, that's not good for you. So maybe as a smart consumer, you say, hey, listen, I don't care what that guy says. I'm going to operate in my own boundaries. And you say, I know that with my income, I can afford a payment of $3,300 per month. I know that my loan is going to be 30 years times 12 months, 360 months. I know that my rate is going to be 5% divided by 12, or 0.417%. I need to know how much loan can I take out knowing that it'll go to here. So what we're solving is this. If you can afford to put out a payment of $3,300 a month, given this time and interest component, how much money can you take out up here to pay it off safely? Scavenger hunt. Plug them in, and you will see you'll get 614,450. And now you've established the safety zone, the most that you can take out in your mortgage to keep your cash flow intact and to make sure you're making a good, sound decision and not overextending. Tools help you. Let's do another payment one. Let's say that you take out a $40,000 11% loan for a new car. The loan's going to be repaid in 6 annual payments. How big will your payment be? Okay, pretty straightforward. We know that you're going to be we know that you're going to be taking out $40,000 in a loan. That's coming to you, so it's a positive number. It represents the present value of this series of cash flows. If you think, how's it a cash flow, Eric? It is a cash flow. You're taking $40,000 today, and over time, you're going to pay it off. When you eventually pay it off, it'll be down to zero because again, you're paying off your loan. Now in this case, it's got 6 equal annual payments, so N is 6, and your car loan has a rate of 11%. So this one, easy peasy. You just plug in those numbers into your calculator and you get 945,506. This means that you will have to send in a payment of $9,455.06. Here's a little extra trick. If you were to take 9455.06 and multiply it times 6, that will tell you the total amount that you're paying the bank. If you then subtract the $40,000 of the loan, the resulting amount tells you how much interest you have to pay. And it's probably going to be a scary number. Okay. Now, let's do an adjustment. Let's just say that instead of annual payments, now it's monthly payments. I would have tried to trick you on this, but you're way past being tricked now. You've got this thing down. You say, Eric, easy. It's just an adjustment. We're still going to borrow and take out $40,000. We're still going to pay off the loan, which puts the future value at zero. But now our N, it's monthly, so we're doing a 12 multiple. So 6 months, 6 years times 12 months, 72 periods. Your APR is 11%, but the A stands for annual, so divide that by 12, and we'll get the monthly interest rate of 0.917%. A couple of easy adjustments, run them back in the calculator, and now we say, oh, if it's a monthly payment, it's $761.45 out. Notice again, both up here and down here, the PMT is negative because you're sending the money out because you're paying off the loan. Let's do a couple more and then we'll call it a day. And again, listen to these, pause them, go to the calculator, practice. And you don't need to do all of them, but maybe if you're stuck on the homework, do these for some reinforcement. Now let's think about the big picture of retirement. Here's the hardest question you'll get in the entire course. You plan on working and saving for 30 years, at which point you'll retire and live off your savings. Good for you. You expect to earn 4% on your investments when you're retired and 7% on your investments while you're working. So while you're working, you're going to be in riskier investments that give you a higher rate of interest. And then once you retire, you'll go really conservative to protect yourself. You plan on being retired for 25 years, and your goal is to bring in $5,000 a month in retirement income. Here is our big operative question. How much do you have to save each month while you're working to achieve this goal? It is a tough question, but to understand it and break it down, all we have to do is think about this. Imagine your life is 2 windows. You have your retirement window where you're pulling out PMTs in, and you have your working window where you're working and saving. Here's how you plan your retirement. You figure out how much PMT you want every month in your retirement. You use time value to calculate this number here, which will be your nest egg. Your nest egg is your retirement amount that you can live off. Now check this out. While you're retired, your nest egg is your present value. So the amount of money in your nest egg the day that you retire, that's your present value that you're going to live off. But check this out. While you're working, your nest egg is your future value. So that nest egg amount is the future value that you're working toward, saving toward while you're young and working. It then converts to your present value that you draw off. Your whole life is a simple cash flow. And now you can plan your retirement out. Let's do it. Okay. First things first, in retirement, you want to bring in $5,000 and we'll say per month. You know that you're going to be alive, you say, for 20 years at 12 months. We have to do an adjustment. That's 300 months. We said that you can earn 4% interest, but we're going to divide that by 12. So you're going to earn 0.33%. The present value, this is your nest egg amount. This is what you're solving for. And because you want it to last for 25 years, at which point it's empty, your future value, which is basically your predicted amount when you die, is going to be zero. Sounds like a lot, but once you get past the mechanics, plug them in. We do a little scavenger hunt, and we get negative 951,238.15. What does that number mean? Well, it means this. If today you decided to retire and you had $951,238.15 in your nest egg, and you could earn 4% on that per year, you could safely pull $5,000 a month for 25 years. Not bad. So that becomes your present value on the first day that you retire. But notice that while you're working, that's the amount that you're saving toward. So your future value while you're working is 951,239. We'll assume that you have no savings, so your present value is zero. You're going to work for 30 more years, so your N is going to be 30 times 12, or 360, and you can earn 7% when you're working. So 7% divided by 12, you'll earn 0.583% while you're working. So what does this mean? You're asking the question, how much do I have to save every month, assuming that I can earn 7% a year, so that I'll have 951,000 in 30 years? Plug them in, negative 780.34 per month. And you've just mapped out your retirement. If these were your numbers, you say, I got it. I set aside $781 a month, earning 7%. 30 years from now, I'll have enough of a nest egg to retire and then draw down that money. And there you go. Okay? One of the hardest things to do, and you got it knocked out in 5 minutes. Easy stuff. Have a dream, have a goal, and use the tools to plan it. You can do this. Final one. You just decided to retire. We're going to turn it around a little bit. You have $850,000 in your retirement account. You expect to earn 4% on your investments and expect to be alive for 30 more years. We want to know, how much money can you take out of your account annually such that it lasts you for 30 years? We want to know, how much can you take out annually so that it lasts you for 30 years? So here we go. We know that you currently have $850,000. We're going to make that a negative because you're going to be putting that nest egg into an account to draw interest. We know that you want to be alive for 30 more years, at which point you're okay with the account having zero, and that you can earn 4% per year. We're solving for PMT. In other words, we're asking, how much money can you take out of your account every year such that $850,000 growing at 4% will last you for 30 years? Plug it in, and you get $49,155.58. And now you know I have an exact amount that I can take out so that I don't outlive my money, retire, or spend my last years in poverty. You can plan accordingly. This is time value of money, my friends. I hope this video helped. Good luck on the homework. If you have any questions, come and talk to me. I'll see you soon.